Relational Databases 101. A relational database is a collection of data items with predefined relationships between them. These items are organized as a set of tables with columns and rows. Tables are used to hold information about the objects to be represented in the database. Each column in a table holds a certain kind of data, and a field stores the actual value of an attribute. The rows in the table represent a collection of related values of one object or entity. Each row in a table could be marked with a unique identifier called a primary key, and rows among multiple tables can be made related using foreign keys. This data can be accessed in many different ways without reorganizing the database tables themselves. This is what you can expect a table to look like. As we discussed previously, it's a series of columns for specific data values that we call attributes, along with a bunch of rows with the records inside them that we call the tuples. The tuples are identified by their primary key, which in this example is the customer ID. The features of relational databases are as follows. SQL. SQL, or Structured Query Language, is the primary interface used to communicate with relational databases. SQL is used to add, update, or delete rows of data, retrieving subsets of data for transaction processing and analytics applications, and to manage all aspects of the database. The second feature is data integrity. Data integrity is the overall completeness, accuracy, and consistency of data. Relational databases use a set of constraints to enforce data integrity in the database. The third one is transactions. A database transaction is one or more SQL statements that are executed as a sequence of operations that form a single logical unit of work. Transactions provide an all-or-nothing proposition, meaning that the entire transaction must complete as a single unit and be written to the database, or none of the individual components of the transaction should go through. In the relational database terminology, a transaction results in a commit or a rollback. Each transaction is treated in a coherent and reliable way, independent of all other transactions. And the last one is ACID, or ACID compliance. All database transactions must be atomic, consistent, isolated, and durable to ensure data integrity. The shorthand for these properties is called ACID. Atomicity requires that either transaction as a whole be successfully executed, or if a part of the transaction fails, then the entire transaction will be invalidated. Consistency mandates that the data written to the database as part of the transaction must adhere to all defined rules and restrictions, including constraints, cascades, and triggers. Isolation is critical to achieving concurrency control and make sure each transaction is independent unto itself. And lastly, durability requires that all of the changes made to the database be permanent once a transaction is successfully completed.